Hello everyone, today I want to show you how you can take the derivative of x to the x using base e, okay? So using base e is basically a technique for differentiation in which you can turn an exponent into a product, okay? That is basically like the main idea. You want to grab any exponent that you have and you want to turn that exponent into a product between two functions or two numbers or whatever you have, okay? But that is basically like the main idea behind using base e. So I'm gonna use that technique for finding the derivative. So let me show you what we're gonna do. We're gonna say that x to the x, we know that it would be equal to e to the ln x to the x, okay? And we know that is true because there is a property of logarithms that you should have learned when you were studying pre-calculus, and that is that a to the log base a of x is gonna be equal to x, okay? Basically, this a and this a they cancel out. And if you want to see a quick proof, yeah, I guess we can do it. You can define y to be equal to, I think it should be, y is going to be equal to, yeah, y is going to be equal to e to the ln x. This is the same as a to the log base a. In this case, you have e to the log base e. So now, if you have this, you can quickly take ln y, this is supposed to be an n, ln y is going to be equal to natural log of e to the ln x. Now you can move this exponent as a product, so you're going to have ln y is going to be equal to ln x times ln e, and you know this would be equal to ln x, okay? Because ln e equals 1. So you have that ln y equals ln x, and since you're taking the log on both sides, that means that y is equal to x, and if y equals x, then x equals e to the ln x, okay? Because we said that y is also equal to e to the ln x, okay? That's basically the proof for that equation. Now, it is very important that this is clear to you because you need to understand that this equation is true, okay? We didn't come up with this just because, this equation is true and you just saw the proof. And you also know that you can rewrite that equation as e to the x times ln x, okay? This is something that you can do. And now, if you want to take the derivative of x to the x, well, you can take the derivative of e to the x times ln x. So let's do that. So we're going to say that the derivative with respect to x of x times ln x is going to be equal to, so we know this is pretty simple, we can just write the initial function e to the x ln x times the derivative of, you can, if you want to see it as a chain rule, you can say that du over dx, where u, that's supposed to be a comma, so where u is equal to x times ln x, okay? And this is basically a chain rule. So you also, you can write this as e to the x times ln x times du over dx. So we know this would be the derivative of this. Now we can use the product rule to solve this. So we know that, let's take the derivative of x first. So the derivative of x is 1, so we write times ln x plus, now we leave x just as it is, and we take the derivative of ln x. And we know that it's going to be 1 over x. So you have x times 1 over x, okay? And this is basically going to be equal to e to the x times ln x times ln x plus 1, okay? And if you have this, well, this is basically the entire derivative. And you can actually simplify this to, so you know that e to the x times ln x, you have it here. You also know that it is equal to x to the x. So you also know that the derivative of x to the x would be equal to x to the x times ln x plus 1, okay? This is the derivative you were looking for, okay? So this is the entire problem. It is pretty simple as long as you know how to play with different logarithmic properties. You need to know that if you have log base something of b, let's say b to the n, you can move that n to the front and then multiply by log base a of b, or log base of something b. And that is something that you can do, and that is something that we used when we moved this x to the front of ln x, okay? And you need to know those properties in order to, well, to get to this derivative. And that's pretty much it, okay? You need to be able to play with different logarithmic properties, and you're going to be able to do really good things, okay? So yeah, that has been everything. I hope you enjoyed this video, you learned something, and see you in the following one. Bye.